All right. First of all, really, my name is Kartik Chandran. I work with Arista. I've been there for ages and I've been involved in SONiC for the past 5 or 6 years, bringing SONiC to advanced architecture like the modular chassis and so on. And recently, I've just joined the governing board as Arista's representative. So looking forward to participating in this event and seeing where we can take SONiC. Before I start though, I just want to give a shout out to Google, to Mithil, to Bhagat, and the entire Google team for hosting this event. So let's hear it for them. Really appreciate it. And looking forward to hearing and learning all about some really exciting talks that are on the docket. So we will kick things off. I guess I use this. Yes. Okay, great. So we'll. I think the presentation is still. Yes. Okay, good. All right, so we'll kick things off with a topic that I know is on a lot of people's minds as they work in the community, which is just being able to create a place where we can develop and ship software efficiently. And I'm just going to dive right into paint the initial picture of where things stand with SONiC and how it's evolved and grown over the years. And you can just see that along any possible dimension you can imagine that SONiC is growing and it's growing fast, right? And especially notable is the number of topologies that are being supported, which are reflective of the number of roles in which SONiC is evolving to operate in. And with this means more participants, more changes going in, more opportunity to break things as you make changes. And so you end up with inevitable scaling and challenges and instability. And so instability is a vicious cycle, because if you start off from an unstable place and you want to ship a release, then you're spending a lot of work and energy trying to stabilize the release, putting fixes into the release, and all of those changes then have to flow back into the main branch, in this case master, and those changes collide with new features being developed on master. At the same time, if master is unstable, then there is no confidence that as new features are being put in, that you've not broken something even further than what was already the case. And so this ends up having a very negative effect on the ability of the whole community to make progress. And so it's really important for us to be able to focus on master itself, and it be as a goal, as a community goal, to be able to put in energy to stabilize and make sure that it stays stable, right? And so just to make things a little more concrete, I did a quick pass about 50 regressions that we hit in the last year or so, just sampling issues that we knew about. And if you break this down, this is not by no means a scientific study, but it's just the intention is to kind of paint a picture of the nature of issues that you end up seeing and what can be done about them, right? So the interesting thing that I noticed is that it's, in a lot of cases, all that was needed to be done was somebody actually ran the code in the right way, and you would find the problem. It was quite visible. It's just that people didn't have, I need to run the code, I need to load it on a particular device, and it'll pass or fail. It's there are many cases where changes merged, where it was missing sanity testing. The other common case is where you make a change that is working for a certain topology, it breaks a different topology, or that you make a change for a certain architecture and it breaks a different architecture. Another pattern is where you make a change in the product, but you don't update the test, and so the test breaks. For example, some UI changed, the format of a command changed, and the test wasn't updated to reflect that. And then you get the inevitable feature interaction. You get issues with the SI that comes in, like it wasn't tested, integrated along with SONiC, and you have interface issues. So the point being that this is a multifaceted problem, and we need to come at it from multiple angles. And that's what we'll try to explore in this talk together. Another interesting view on regressions is that there are a lot of important structural challenges that we face. Starting off with a lack of baseline, right? It's not possible to know the health of master at any given point in time. You have no visibility into it, right? So you don't know what issues are open. It's very hard to tell between if you're trying to make a change, whether it's the breakage was introduced by your change versus an existing change in master. Right? And inevitably, what happens is that teams are operating in silos, and so they absorb a new version, and they all discover the change, the issue in parallel. They're triaging in parallel, and maybe come up with different solutions, and then it comes up in the community. There's a debate, and fixes get pushed in, and it takes a while. It takes a lot of friction to get the changes pushed through. And what's the other thing that's really unique about SONiC is that there are some organizational boundaries that you can't ignore, right? There are competitive concerns. So proprietary aspects of one participant can't be shared with another. And if I'm making a change to support the architecture that I work on, it's impossible for me to test on a different architecture. It's fundamentally impossible. There are fragmented communication forums. So all of this adds to the friction in being able to both view the stability as well as improve the stability over time. So now, having laid out the nature of the problem, Bhagat and I, we kind of brainstormed, and we try to come up with how can we come up with a concise set of messages that we can all rally around as like kind of guiding principles around which we can organize ourselves within the community and be able to make progress, right? And so we came up with this 4 V's message: validation, velocity, visibility, and vigilance. So I'm going to hand it over to Bharat to kick off.
Thank you, Kartik. So validation, these 4 V's are not new to us. These are things that most of us are already doing. What we wanted to emphasize is we need to do more of these, right? We already are doing validation in SONiC in many ways. We want to probably start doing more data plane validation in virtual ways as well. Also test in multiple different topologies, not just the topologies that we are used to. Test for the community, not just test for one particular deployment, right? And then the message that Kartik was mentioning earlier, you have a higher confidence on mainline, and mainline, just works. For making sure mainline just works, we want to test before commit, not after commit. So today, a large amount of testing happens after. And this means we need a stable virtual SONiC that supports data plane. There are community efforts, Alpine, VPP, and others which are helping in that direction. We also want to integrate testing in a lot more into the CI/CD pipeline. Right? So these are changes that we need to go ahead with. And how do we increase velocity? By velocity here, we don't mean feature velocity. Feature velocity is a product of test velocity. Right? So the faster you are able to test, the faster you're able to qualify, the faster you're able to bring in features. And this is not something new again. It's how do you classify tests, group tests on particular topologies and particular functionalities? Once you group them in that way, the bring up for the test can be common, and then you test multiple things with the same functionality, same topology, and then you do a teardown. So that shares the bring up and the teardown time. Sometimes bring up and teardown time can be in order of minutes, and we want to share that, right? So those are things that we want to do to increase the velocity. Component testing is not new again. It's something that we do, but the percentage of component tests that we do to the amount of code that we have today in the SONiC repository is relatively low. We want to increase that. And so those are the first 2 E's. I'll hand over to Kartik for the next 2.
And the next is the topic that has come up multiple times, and I've also this was highlighted even in the community test bed topic, is being able to have a community visible pane of glass that everybody can rally around as here is what master is like on a given day, and potentially leveraging the public test beds or even virtual test beds and other creative ways by which we can make results available and get good telemetry on the health of master at all times, and turning that into a dashboard that everybody can point to and say, this area is broken in this particular feature or function at all times. And that acts as a rallying point for the community to take action instead of everybody discovering issues in their silos. And then once we have that, then it provides a way for us to automate workflows both in the community as well as external to the community, where we can potentially integrate when we are making a change that we intend to publish. You can measure it against the data that you have on master. So it opens up all kinds of possibilities for us to be able to get ahead of the problem. And last but not the least, this is, I think this may sound as motherhood and apple pie, but there's a really strong cultural element that we need to instill in the community of that of vigilance, which is always taking the stability of master very seriously. Thou shalt not break it mentality. And this means that as we are making changes, we all need to be able to instill in the submitters this idea that you should be careful about not breaking things outside of your domain. And obviously, we need to support that with additional machinery that the community can provide to aid submitter, but it ties together along with a cultural mindset. And so with those, I think I'm going to turn it out to Bhagat to talk about a real case study. This is Google's experience on how they've actually adopted some of these principles and tied back to the kind of high level points we made, just to get across the message that this is actually possible to do. And it requires some dedicated focus and attention, and the community kind of coming together to realize the importance and the value of operating in this way. So I'll hand it over to Bhagat.
Thank you, Kartik. So as Michael mentioned in the beginning, 2021, we announced SONiC for SDN. And critical goals for us right from day one was high quality and lip shifting validation. Lip shifting is a term we use often internally to say how you could bring validation as early as possible. And that eventually helps you to do feature velocity. And the multi-pronged approach we used was pretty much the same 4 V's that we talked about, right? Visibility and vigilance, we have sanity runs that run every few hours across sanity pipelines. So our main line that we have is tested very quickly every few hours. And if there are breakages, they are identified, they're displayed on dashboards, so we quickly know that something is broken. We're able to go back and roll back a cherry pick, roll back a change if there is a new breakage, right? We also have nightly runs that run a lot more tests. So every day we have a score for our daily image, and that helps us ensure that a dip in the score is very quickly identified, and we work towards higher quality. And of course, we have the longevity and soaking test bits as well, which run tests for more than a week, a month, things like that. We have reports that come out of these, and we are able to release many releases over a year. So that's something that we do internally. And one of the things that we would like SONiC also to be able to do is to move ahead from this 2 releases per year to multiple more releases per year. And then the way to go there is to have a systematic way of testing hourly, daily, and over weeks. Right? Velocity, we try to simplify topologies. A good number of tests, frankly, can be done in a single switch. And a lot of tests, pretty much every test, can be done with 2 switches or a switch and a packet generator. Once you simplify the topology, you could batch things much more easily. Your topologies are simple, so you can parallelize them, and then you can start running them faster and faster. Let's come to component test. So we took, I'm taking an example of SONiC component test here. And what we did was we basically bring up SONiC, and our test runner lets the initialization to happen and then pass a Swiss. What this allows us to do is have a separate test binary be inside Docker Syncd and run the SI implementation through a series of tests. Right. So this tests almost all the APIs very quickly in hardware, ensures that when we move from SI version X to SI version Y, there is no breakage, right? So these are things that we have done. We were planning to upstream this and provide it to the community. This is a faster way of testing SI APIs and can be used to evaluate that when we go from version X to Y, we're not introducing any new regressions. Moving on to validation. So we are working on pre-commit validation now. Alpine, which we have been talking about a lot in the community. Sonika gave a talk yesterday. So this is something that we truly believe in, and it covers a lot of things. We are also very happy with the VPP effort that is going on in the community. We are completely supporting that as well. This is now integrated into our CI/CD pipeline. What this allows us to do is, before code is checked in, we can test and validate that it is not breaking anything, right? So in fact, it has helped us in the last 6 months to identify more than 100 issues. Half of these issues are on new platforms that we just started. So it also brings in a velocity towards newer platforms that we adopt. Right? So we believe strongly in this, and we also are working towards giving this to the community. The call to action, I think all of us know great software is built on a foundation of quality. Quality is extremely important, and the 4 V's are not new. It's just a way to give a message of things that we already know. And the test working group is quite active already in the SONiC community. We would like more and more folks to join it and participate in the test working group for healthy SONiC.
Yeah, and there's going to be a workshop in the afternoon, a breakout session on this topic. So you're welcome to join, and we can talk about some of these topics at more length. All right, with that, I guess.
Any questions?
Any questions? Reactions?
There are 2 mics at the back in case there are. Yeah, please go ahead. If you could pick up that as well.
Thanks for the presentation. This is an interesting topic. One of the things I wanted to ask is, have you looked at, from the architecture point of view, that are there any weak spots now in SONiC, since it has grown over like multiple years? Initial use case, it started with something, now it is going in various use cases that something need to be redone.
That's a very interesting question. I think we should definitely look at the way, like I said, sometimes we have the tendency, because as Kartik also mentioned, SONiC community is made up of disparate members. Each person is working for a particular topology, particular use case, right? We need to come to a common mindset where all of those use cases and architectures are thought about, and how do we strengthen the different components together. Kartik, anything to add?
I guess my reaction would be no question that we need to look at areas where there are potentially architectural weaknesses, but the way to find those out is actually to have a unified pane where we can all see that, hey, as changes merge into SONiC, we see repeated issues in a certain area, and you have the data to support that. If you can drive action through that data-driven approach, then I would think that would lead to more effective outcome.
Brings it back to visibility and dashboards.
That's how I would see it. So at this point, there is no common understanding of where the weaknesses are. The visibility isn't clear across the community. But when we can all see it on one page, then it focuses the efforts more effectively to in the direction that we want to go.
Thank you.
Do you have any thoughts on the code review process?
Thoughts on the code review process? I think you want to start.
Yeah, I do think that I know that this has been an active topic in the community, that code review bandwidth has been limited. There are cases where reviews, and I know that a lot has been done already to add more maintainers to various SONiC repos. There is an initiative going on to make sure that there is enough visibility and attention to code reviews. I'm sure we can do more. And of course, if I would suggest bringing proposals to the TSC if people have ideas, TSC is always listening.
And Michael made a reference to
Yeah.
this partly right in the beginning in his keynote, where he said we have maintainers and we have working groups, but we need a lot more participation. And 2025 has been a year where everybody is busy. I know all of us are working towards getting the next product out. So it is a busy time for our organization. So it is very difficult to also find time for community effort. But at the end of the day, finding time for community effort makes all of us faster, right? And making sure that SONiC is solid and high quality also increases our velocity. So it is to be a little bit of a give and take in this. I think despite the busyness in which we all find ourselves this year, let's start focusing more and helping out more in the community. Again, please join the test working group meeting today. And Richard is indicating the time is over now, so we'll take other questions offline. Thank you.